I want to talk about degree of freedom, and at the end of this, you'll be able to understand what the degree of freedom is, and also you are going to understand the use of degree of freedom in statistics. For us to understand degree of freedom, first we have to understand one assumption, and that is assumption of statistical independence of observations. In this assumption, the random components of data are independent and identically distributed. I want you to note the word independent. Assume that you have a sample of 4 plants and you are interested on their heights. You want to do analysis of variance. The first step is to get their mean and also get deviations from the mean. In other words, you are going to subtract the mean from the height of each plant in this sample. And this is going to give you a table like this, which has deviation from the mean. We all know that this deviation from the mean, they sum to 0. With that knowledge, if you are given a table like this, but you are not given the height of individual plants, and you are requested to provide the deviation from mean of two plants that whose values are missing, this is not possible. But if you are given a table like this with a sample of 4 plants, but 3 plants have their deviations, and you are requested to provide the deviation from mean of 1 plant, for example plant 3, you will be able to provide. This is because the value of plant 3 is attached to a constraint, which is the sum of deviation from the mean that is 0. Therefore, this value of plant 3 has to be a value that will satisfy these constraints. The rest of the plants can take any value. They are free to vary and they are independent. But plant 3, the value of plant 3 has to satisfy this constraint. In other words, in a sample of 4 plants, 3 plants are independent. They can be any value, they can vary, and therefore they are the degrees of freedom. In the samples that we take when we are doing research, in that sample size, only one observation is not independent, and that observation is removed to give degrees of freedom. Therefore, degree of freedom is the number of independent pieces of information that are available to estimate a parameter or quantify variability. I want you to connect this word independent with the statistical assumption that we discussed, and again with the explanation that I've given on degrees of freedom. Having understood this, let us now learn how we apply these degrees of freedom in research or in statistics. Assume that you have a population, and in this population, it is normally distributed and it has its mean here with this simple mu. You need to collect a sample from this population. In sample collection, the sample may fall on this side, whereby you get that this sample mean, x bar, this sample mean, is less than the population mean. I want you to note that the observation on this blue line, they are near the sample mean, but far from the population mean. That means the deviation from the mean on the observation in this side, they are going to be less compared to the deviations from the population mean. And in other words, these data points here, or these observations here, they are an estimated deviation. They underestimate the population. I also want you to note that in this sample, majority of observations are underestimated, while a few of the observations here, they are near the population mean. On the other side, the sample may fall to this area of the population, whereby the sample mean is larger compared to the population mean. And you see that all these observations here, they are near the sample mean. Therefore, compared to the population mean, the deviations are going to be underestimates. In general, it has been observed that sample underestimates the population parameters, or the sample statistics underestimate the population parameters. The use of degrees of freedom corrects sample statistics from underestimating population parameter. For example, in the computing of sample variance, we use degree of freedom, where one observation that was not independent is subtracted from the sample size. If we use the whole sample size, this value here, the sample variance is going to be underestimated. But if we remove this one observation that was not independent from the sample size, this variance is going to be increased a little bit, and thereby correcting the correcting underestimation of the population parameter. That is it for today. I hope this was helpful. Kindly subscribe, like, and share. You can also comment.